longer leg of a right triangle is 1 centimeter less than twice the shorter leg. Well, since it is a right triangle, I'm going to draw a quick picture here. Here we go. We've got a longer leg and a shorter leg, definitely. The longer leg is 1 centimeter less than twice the shorter. So if the shorter is x, the longer one will be 2x minus 1. The hypotenuse is 1 more than twice the shorter leg, so 2x plus 1. Okay, I can apply the Pythagorean Theorem again, and that's a squared plus b squared equals c squared. So I'm going to have x squared plus 2x minus 1 quantity squared equals 2x plus 1 quantity squared. And I'm going to slide this up here because we're going to need our space. Do not make the mistake of just squaring each number inside. This is actually a FOIL problem in each of these cases, so I'm going to write it as such. X squared plus 2x minus 1 times 2x minus 1 equals 2x plus 1 times 2x plus 1. Now let's do all the distribution out. We have x squared plus 4x squared minus 2x plus 1 equals 4x squared plus 2x plus 2x plus 1. Combining like terms on the left, we have 5x squared minus 4x plus 1. And combining like terms on the right, we have 4x squared plus 4x plus 1. Now we want to take this quadratic equation and set it equal to 0. So each term on the right is going to be subtracted off of each side. So subtracting, we have minus 4x squared, a minus 4x, and a minus 1. And we will be left with x squared minus 8x equals 0. This now factors into x times x minus 8 equals 0, and x will equal either 0 or 8. Well, the length of a side of a triangle cannot be 0, so we have a reason to cross that off, and so 8 centimeters is going to be the length of the shortest side that we're looking for. Write a quadratic equation whose roots are, now roots basically means solutions, are negative 1 and 4. Okay, well, that means x plus 1 times x minus 4 will be part of my quadratic equation, specifically so that when I go backwards I get those zeros, whose leading coefficient is 3. Now when I multiply this out, it's going to begin with a x squared. I want it to be a 3x squared, so I'll put a 3 there. Now, a quadratic equation, I'm going to put this in standard form, so I'm going to have 3 times x squared. Now I'm going to have a minus 4 and a plus 1, so minus 3x minus 4 equals 0, and we now have 3x squared minus 9x minus 12 is equal to 0. That is a quadratic equation in standard form with a leading coefficient of 3 that does have solutions negative 1 and positive 4. A 17-foot ladder is leaning against a wall. Okay, here we go. Here's my wall, here's the ground, and here is the ladder. Okay, draw a picture. The distance between the base of the ladder and the wall is 7 feet less than the distance between the top of the ladder and the base of the wall. So if this is height minus 7, and it's a 17-foot ladder, so I can label the 17 right there. Find the distance between the base of the ladder and the wall. So I really want my h minus 7. Now I'm going to try a little trick. I can solve it this way if I want to, but if I change this to an h and change the other to an h plus 7, then the value of h that I solve for is actually the answer that I'm looking for. So I'm going to leave it in this form here. Now I'm going to apply the Pythagorean Theorem. H squared plus h plus 7 quantity squared is equal to 17 squared. And we're going to rewrite this as h squared plus h plus 7 times h plus 7 again is equal to 289. It's cleaning up now. We're going to have h squared plus h squared plus 7h plus 7h equals 289. Combining like terms, we have 2h squared plus 14h, and I'm going to subtract the 289 on each side right now to set that equal to 0. And then I've got some really big numbers. Oops, I see what happened. I forgot my plus 49 right there, so that when I subtract the 289, this is really a negative 240. Okay, good catch. So factor out the 2, h squared plus 7h minus 120 is equal to 0. Let's factor this and see what happens. H and h, and after some discovery, it's going to be 15 and 8 multiplied together makes 120, subtracts to make 7, so that would be a positive, and this would be a negative. We can ignore the 2 out in front, and h will be negative 15, which makes no sense, so h is going to equal 8 feet. And that's the value we're looking for, and it kind of makes sense when you apply it up into the problem. Find the x and y intercepts of this function. Now let's think about this. When I have an x-intercept, it's going to be at some number x, comma 0, and when I have a y-intercept, it's going to be at 0, comma some number y. So whenever I have an x-intercept, y is 0, and whenever I have a y-intercept, x is 0. So let's start by letting y be 0. If I have 0 equals x plus 1 times x minus 2 times x minus 3 squared, that's already a factored polynomial equation, and we can use the zero product rule and see that the solutions are negative 1, 2, and 3. And that tells me that the x-intercepts are going to be, this should be let's try it again, negative 1, 0, 2, 0, and 3, 0. Now as far as the y-intercepts go, I'm going to let x be 0. So I go back to the original problem, which I'm going to write down, f of x, but let's write that as f of 0 will be 0 plus 1, 0 minus 2, and 0 minus 3 squared. That becomes 1 times negative 2 times positive 9, and we get negative 18. And that tells me that the y-intercept is going to be at 0, comma negative 18.